Suppose that $15,000 is invested at 5% annual interest, compounded continuously. How much will be in the account in 5 years if no money is withdrawn? For continuous compound interest, we have the formula A. I always call it the A equals PERT formula. PE to the RT, where P is the principal, R is the rate, and T is the amount of time measured in years. So if we're talking about 5 years, then we're starting with $15,000, that's our principal, times E to the 5% is 0.05 times the number of years, which is 5 years. We go to the calculator to get this answer. We get $19,260.38. So if we invest $15,000 at 5% annual interest, compounded continuously, meaning that it's always being compounded, after 5 years, if we don't withdraw any money, we'll have $19,260.38. The next part of this question asks us that if we have the same situation, we have $15,000 and it's 5% annual interest compounded continuously, how long will it take for the initial principal to double? So now we're talking about the amount of money being $30,000. We need A to be double what we started with, which was $15,000. And that gives us $30,000. We're still using the A equals PE to the RT formula. So we have 30,000 is equal to 15,000 E to the, I know the rate, that's 0.05, but what I don't know is T, the amount of time that this is going to take. So in order to get this into an exponential form, where it's just e to some power is equal to some number so that I can use logarithms, I'm going to divide both sides by 15,000. So we get 2 is equal to e to the 0.05 t. Rate this is e to the 0.05 t is equal to 2. An interesting fact about this problem is that it doesn't matter how much money that you started with. When we divide, this number over on the left-hand side is always going to be 2. If I started with $10 and then wound up with 20, when I divide, I'm going to get 2. So the amount of time that it takes for something to double when we're talking about continuous compounding is independent of how much that we actually start with. So now we're going to take the ln of both sides. So we have the ln of e to the 0.05 t is equal to the ln of 2. And the ln and the e are inverse functions of one another. They cancel, or if you want to think about this as the power coming down, the 0.05 t coming out in front, and we have the ln of e, which is just 1. The left-hand side here just becomes 0.05 t. The right-hand side is the ln of 2. And so we get t is equal to the ln of 2 divided by 0.05. When we go to the calculator and do the ln of 2 divided by 0.05, we get approximately 13.9. And that was measured in years. So the amount of time for the amount of money in the account to double would be about 13.9 years.